Hello, hello. Microphone? Yes, working, I guess. Uh, Hello. I'm going to be talking about low code and robot framework, babbling on for about 30 minutes. I made these slides last night, so we can find out together what's actually in them. I'm Ossi Rajuvara. I'm a team lead at RoboCorp. Currently, we have a 5-person team working on a new product we call Automation Studio. It's been going on for about a year now, not quite a year and a half. And going back, I want to define low code a bit. We come from RPA, and these are sort of two well-known RPA tools. On the left, it's Blue Prism, and on the right, it's UiPath. And they define low code as this sort of visual programming language. And for instance, like Blue Prism on the left, it modeled very closely to like business processes. So it's RPA is close to business processes, so they figured out that maybe the actual programming should resemble that closely as well. And the thing is that these are like, in the RPA, they talk often about citizen developers. That's like non-technical people automating things, often business users that have domain knowledge, but they don't have the technical know-how to actually program something. But low code isn't strictly just that. I don't really buy the citizen developer thing that much. But low code can also sort of enable a professional developer. And low code can mean a lot of things. It can be this sort of thing. It can be code generation. It can be, I don't know, for instance, spreadsheets are a type of low code. RIDE for the Robot Framework IDE is, I think, on the spectrum of low code. It just has a different goal. And I think the bottom line is that low code reduces the need to code to some degree and some way. And that really sounds like the pitch of Robot Framework in general. If you look at what a simple example of Robot Framework is, it looks like this. I wouldn't call this code on a lot of levels. It's almost like a readable story. But I think this is a simplified view of what the reality often is, especially in RPA. Often when you get into a project, it's going to look a bit like this, I think. And that comes partially from the nature of RPA. It's different than test automation. In RPA, you have to work despite of the bugs, and you work with inputs which affect your control flow, and you have a lot of things to consider. I think Erno tomorrow will talk a bit about the differences between RPA and test automation in general, but it is a sort of, this is the reality often. And you can, of course, refactor this and make it pretty like in the first image, but the underlying complexity is always there. And you come into this as a newbie, the variable syntaxes, the control flow syntaxes, everything it's really sort of quite a lot to take in. And low code isn't really just about that syntax. It's a lot of things around it and on top of it. So just installing Robot Framework and Python, installing your libraries for Robot Framework, and where do you find the documentation, and how do you call those keywords? And then your applications, you need to build selectors, you might want to record an interaction and build something out of that. And then in RPA, those inputs and outputs are critical. So you take something in which affects your like execution flow of your robot. And then integrations, you integrate into email systems, into like document processing things, and all of these things which are not strictly writing code, but are like consume your time as a developer. But really, I think for a newbie, the big barrier to entry is the syntax. So it might seem a bit silly to a lot of us, but for a lot of users, text-based programming is a challenge, and they don't really understand how to even read text-based like programming. And it's not just like these sort of business users. It's like people who have been maybe years into RPA, and they've used these low-code tools before, and they know their domain quite well, and they've automated things before. But just reading this sort of script can seem like daunting because they don't have the sort of tools to understand how that even works. And the fact is that Robot Framework is quite complicated. It's not like, well, it's simpler than C++, but it is complicated. There's a lot of things to sort of learn when you get started with Robot Framework. And when you come into it, you really don't want to spend your time sort of wrangling robot framework and the syntax. You want to focus on what you're actually wanting to automate. You want to solve your problem and not immediately get stuck in some sort of irrelevant detail of how many spaces did I put here and there. So coming back to this example, I assume a lot of people don't really read this as sort of simple text. You have your own mental model of how the code works. You understand the while loops and the try except blocks and the if statements, and you have like I said, mental model of how this code actually works, what's the assignment and what's the actual keyword call and so on. And so does Robot Framework. A Robot Framework parses this, tokenizes it, builds an AST, builds an execution model under the hood. And you see a part of this every day pretty much if you work with Robot Framework. You see it as the result model. The result model is a sort of abstract representation of this code in a way after the execution. And this is very close to how I see the mental model working with Robot Framework. And that's how we modeled the sort of low-code approach to Robot Framework. So here's a small little screenshot of a block-based editor for Robot Framework. You have those keyword calls, you have the assignments, you have the control structures, and they resemble the code quite a lot, but without the actual text-based intricacies. You can have the same functionalities, same control flows, but without typing as much code, reducing the need to code. And I want to show these side by side just to sort of highlight what our goal is. We wanted to build a low-code tool for Robot Framework. We didn't want to build new walled gardens. We didn't want to build new file formats. We didn't want people to learn just our low-code platform. We wanted them to learn Robot Framework. So this code is the visual representation, and the visual representation is that code. We don't, we sort of just have a view into this code. And hopefully, if you get started with this visual tool, you'll learn the high-level concepts of Robot Framework. You know how the control flows work, how the actual execution will happen. And then later on, when you see this code, maybe, you'll understand what it actually does. Then it's easier to learn how the variable syntax actually works, how you write that out. But then the learning curve is much less steep for you. So here I'm going to show a small little demo video that I recorded yesterday on me using Automation Studio. So I'm going to create a small little project here. It's a template for web automation. And when you press create, it creates a new Python environment with all of the dependencies. So here it is. Here's the visual view into it. So if you look at the keywords, it has the inline, the documentation for how that keyword works, and the arguments for the keyword. And you can also note that it's like rich arguments. So booleans are toggle switches, and text is like text boxes, and file selectors are files, and that sort of thing. And you can change the values just visually, just clicking around. And just to sort of highlight what I said previously, if you go to the code tab, it's underlying code. It's always just code, but in a different representation. So there's the value for this boolean toggle. If I go to the code view and I just edit it manually, it's going to reflect the visual side of it as well. So these two are always linked. So for instance, if you build stuff, I'm just going to prove my point here. So I have the palette of keywords, and I click one in there. I can have rich things like autocomplete built on top of it. But if I create something on the visual side, it's always reflected one-on-one in the code side. And further proving the point is me editing this as code and then it reflecting on the visual side. And like I said, low code isn't just this sort of syntax thing. We can now, with our own IDE, build rich things on top of it, like different locator and selector features. Like here are some selectors used in the automation with pretty boring screenshots, but also like XPath selectors auto-generated by the tool and that sort of thing. And you can jump between code, use your keyword definitions, see how they're defined and jump back and so on. And with Robot Framework, we can do other cool things. Like if I run this robot here, we're using the listener API to stream stream a real-time execution of what's actually happening. So fairly trivial from the events in the listener to rebuild that sort of same tree with the same visual blocks from these events. So you could real time, you know what this did, you just implemented it, and the same blocks are there visually in the result. So you know one-to-one how these two things map together, and you understand how it works. Here's an example. And I think that's the demo video. So I think a lot of the time I feel like Robot Framework is a really good tool for creating this sort of low-code tool, because the core syntax is really, really simple. It's doing this for Python. I don't think it would be possible because of how rich and verbose and how many things you can do with it. But with Robot Framework, a lot of the time it's an optional assignment, a keyword colons and arguments, and it's executed in a linear fashion. The syntax is limited, and you can build like rich block-based editor for this. With Python, you could maybe write a code generation tool which made a small subset, but you can't do this sort of linking back and forth in a way we can do with Robot Framework. And Robot Framework comes with really good APIs on the Python level for doing this sort of thing. If you open, for instance, a REPL with Python, just say from robot.api import parsing and look at what's under parsing, and just get simple utilities for parsing ASTs out of code files and that sort of thing. It really enables you to build this sort of tool or any sort of other custom tool. And on that topic, it's really extendable on a lot of points and configurable, like the listener API I mentioned. It enabled to build that result streaming thing quite easily. And in the previous talk on the browser library, Kerkko talked about type conversions. The type hinting in general, as a specific feature, enabled that sort of generated UIs for keyword calls, like the Boolean toggles and the text inputs. Those come automatically parsed from the type hinting in the keywords. But then quite often I feel Robot Framework is pretty bad for this. Or maybe that's not the correct word for it, but it sort of validates the need for a low-code tool, but it also makes my life a real pain a lot of the time. Python environments is one of those things. It's a problem we've tried to solve, I think, from the beginning of RoboCorp, and we have some solutions, but it is a thing we tackle with pretty much every day. Not gonna go too in depth into that. I just wanted to drop that here. And Kari, I think, had a virtual talk on this, maybe. And then one syntax-specific thing is the variable syntax, which I'll go into a bit. So superficially, variables are simple. The syntax isn't the prettiest, maybe $ and curly braces, and as a simple value, it's understandable. But the variable syntax over the years has grown in features quite a lot. And there's quite many things and different sort of features as part of variable syntax that you can use. So my convoluted example is if you run into something like this in code. And of course you can understand it as a user, but then when you're building a low-code tool, how do you express this in a low-code fashion? How do you build a visual design language that can represent this in some way? And our UX designer, Janne Aukia, isn't here today, so I can freely show some designs from him that he doesn't probably want to show. I took a screenshot from Figma, where he's been trying to hit his head on the desk, trying to figure out different ways to represent all of the ways that you can use variables in Robot Framework. And it's not an easy task, and it's probably never going to be entirely finished, but it's part of the challenge of creating something low-code on top of Robot Framework. And then the other thing is conditionals. So here's going into conditionals. Here's one conditional. And I'm not going to bother to make a convoluted example of conditionals because I think this is convoluted enough for Robot Framework conditionals. I know a lot of people who have a programming background and they have a real trouble understanding how conditionals work in Robot Framework. And the thing is that it's not immediately obvious how they function. Here, for instance, I have a quotes around the string. If I don't have them, I'm going to get a pretty cryptic error message. And this even won't work depending on what's inside the variable. And the fact is that, like I said, Robot Framework comes with pretty good parsing utilities for parsing the code into a fancy model, but when it gets to a conditional, it's just an opaque string. It doesn't understand the content at all. And that's because it's sort of implemented in a way which is simple to understand if you know how it functions in a way. This is just replaced a string, the variable, and sent to Python's eval. It's always just evaluated Python. It's not really Robot Framework code as such. And if you want to build a low-code tool on top of conditionals, you don't just have to understand Robot Framework as a language. You need to understand Python. Luckily, Python also comes with a pretty good module for AST parsing. So you can build a conditional builder on top of that. So if you make a if control statement in Automation Studio, it's this sort of innocuous small little conditional builder that works in both directions. But it's also a Python AST sort of generator and parser as well, because it has to. And this is something that also we will probably need constant work in the future. And then I think, like in general, I think the overall complexity of Robot Framework is one of the key problems here. I think over the past year and a half, I spent a lot of my time reading through Robot Framework's user guide and code base. When I think every week I run into a new feature that I didn't know existed. There's quite esoteric features in Robot Framework, but I worked in test automation for 6 years, and I think I used this really tiny subset of Robot Framework in the end. And this is sort of, I think the only way to tackle an editor for Robot Framework is to implement it one small slice at a time. But I think there's a few key issues I'm going to raise here that I think could make Robot Framework a bit better in that regard. I mentioned type hints and type conversions. There's one library that's, or a set of libraries that are the most used that have 0 type hints in them, and that's the standard libraries. Robot Framework's own libraries don't use type hints and the automatic type conversions at all. So, for instance, the fancy UIs in Automation Studio, those are like patched afterwards. We're maintaining our own set of type hints for the standard libraries, which we of course could float back into upstream Robot Framework, and we probably will after some discussions. But it's something that Robot Framework could do a lot better. And the other one is structured documentation. The Robot Framework supports a few different syntaxes for doc strings. It has its own robot format, but it's not really structured. The tables are the same as example sections. The keyword descriptions are part of the body of the text, which reads a bit like prose instead of structured documentation. And the only implemented parser of that documentation is in Robot Framework. I don't think it even has a sort of spec. It just has an implementation. And then you can use restructured text and that sort of thing, but for instance, RST support hasn't been maintained for a long time. It's not, I'd say it's almost not in a usable state for production. And I think if we agreed on some sort of structured unified documentation format, it would be maybe a lot of work, but I think it would benefit on the long run. And then there's the challenges with logging. Of course, the real-time streaming logging thing was cool, but the sort of the official output XML, while it's versatile and Rebot has a lot of features, a lot of configuration options, it still doesn't really serve all of the needs of RPA. RPA process can be really wrong running, so and the sort of the size and sort of verbosity of the log is a problem, and so is compliance. Like official ways of not logging things always would be helpful. And this is not like one single thing to fix. It's, I'd say, a collection of small things that we could look at together as a community. This is the end of the official slides, but I'm going to quickly jump here, going to highlight something here. I have time. So talking about the sort of building on top of an abstract model of Robot Framework is that we have this sort of intermediate representation of the code as more abstract, separate from the code, so you can display it in different ways. One of the views that I didn't show in Automation Studio is the flow view, where you can see this sort of more process flow view of what's happening in the code. And for RPA, this sort of solution documentation is also important when you see what that implementation actually does and what the flow is like. And for the external sort of stakeholder from maybe some business end, they don't understand code and maybe not the block representation, but they, from the process, they would understand this sort of flow of the robot. And because it's the same model always underneath the real-time result streaming, you could just plug this into this flow diagram and it would also work. It just hasn't been implemented yet. But I think that's what I think that's everything.